Welcome to another unit in this exercise set on Statistics 2. This time with a unit on the homogeneity test, so a chi-square test, to test whether two samples share a common distribution. Let's have a look how the exercise for this looks like. Here we have three types of t-shirts are produced in two locations. Depending on the type of shirt, they report the following rejection rates. Now we have location 1, location 2, and we have three types, small, medium and large. The question now is, or the task, use a suitable test to find whether significant differences exist between the two locations. Assume that a margin of error of 5% can be seen as acceptable. So what we're going to do here is we're actually going to test whether the two locations regarding their rejection rates have a common distribution, share a common distribution. For this, we're going to start by calculating first the expected frequencies. I guess if you've done some other exercise on the chi-square test, you know first step always is expected frequencies. So how do we get to expected frequencies here in this case? We start by just copying the table from before and adding an additional row where we have the sums for both locations. So here that's the sum for location 1, that's the sum for location 2. Incidentally, in this case, the sums are identical in both locations here. Doesn't always have to be the case. In this example, it's it. Okay, once we have these sums, we can continue by calculating the possible common or shared distribution. How do we get this? We go there, take for small the two values from location 1 and 2, add them up. So here 1,500, 1,900 give 3,400. Those 3,400 we divide by the sum of the two sums. So we add up 6,300 and 6,300, so getting 12,600. Then we divide the 3,400 by the 12,600, giving us here a ratio of 0.2698. Then we do the same thing for medium. We go here 2,000 plus 1,900, so 3,900 divided again by 12,600, giving us here a share of 0.3095. And finally we do this for large. For large we get 2,800 plus 2,500, so 5,300. Again divided by 12,600, giving us here a share of 0.4206. If we add up those shares, in this distribution, we will again get 1, so 100%. That's actually a good idea to always do so that you can assure that you calculated this correctly. This is the distribution, so those values actually have to add up to 1. Okay, we have the shared distribution, a theoretical shared distribution. What about expectant frequencies? Well, expected frequencies is just one more step. That's relatively easy and straightforward. We simply take these numbers, these shares, and then we multiply them first for location 1 with the sum of location 1, then for location 2 with the sum of location 2. That's why we also get the same values for both locations, because we have the same sums. Meaning, for location 1 and small, what we do is we take 0.2698, multiply this with 6,300, giving us 1,700. As I said, as the sums are the same, I get for location 2 as well 1,700. It's the same, it's the 6,300 here times this value. Then for medium we have 0.3095 times 6,300, giving us 950. Finally, for large, we have 0.4206 times 6,300, giving us 2,650. Of course, those expected values again have to add up to the sums as before. Well, as I said, due to the fact that we have the same sums in the two locations, we get the same expected values in both locations. This, of course, is only the case due to the fact that here the sums are the same. If they were different, we would get different expected values in both locations. Okay, that was the first step for our chi-squared calculation or our chi-squared test. The next step is actually calculating the chi-squared test statistic. Now we're going to do by using the typical formula for chi-squared. So we're moving through all these 6 entries, so 3 for location 1, 3 for location 2, all 6 entries. And we always compare the actual number, 1,500, go with minus the expected number, 1,700, in parentheses, squared, divided by the expected number. We do this for the first one, then we do this for the second one, for location 1. So here we have 2,000 minus the expected value 1,950 in parentheses squared, divided by 1,950, plus, and the third one for large. Here we have 2,800, the actual value, minus 2,650, the expected value, in parentheses, squared, divided by the expected value, 2,650. That was the 3 values for location 1. Now we add the same thing for location 2. 1,900 minus the expected 1,700 divided by the expected 1,700. And of course, here the upper part squared. Doing then the same for 1,900 and 1,950 and 2,500 and 2,650. So for each of the 6 entries we have here, we get 1 term. So if you have 6 parts, you will get 6 parts here. That's an additional way to check whether you did this correctly or whether you missed something. Once we have this, we can just calculate all the different parts, giving us this intermediate result. And if we add all of these numbers up, we get as a final result a test statistic of chi-squared is equal to 66.6041. So for the test, this is actually the first step. We have a test statistic. Now we need a reference value to compare this test statistic against. This reference statistic for the homogeneity test we get via chi-squared I minus 1, 1 minus alpha. I, the large I here, that's the number of rows or the number of different characteristics I have. Here I have small, medium, large. So I have 3 characteristics, 3 types. So my large I is 3. I minus 1 therefore is 2. I had an acceptable margin of error of 5%. So alpha is 0.05. So 1 minus alpha is 0.95. If I look up this value, chi-squared to 0.95, I will get a value of 5.9915. And then, for my test itself, I simply compare test and reference statistic. As with most tests, if the test statistic is larger than the reference statistic, that's what we have here as well, this means we can reject our H0 hypothesis And the H0 hypothesis in the context of the homogeneity test means that both samples share a common distribution. So here it's rejected. So this means both samples do not share a common distribution. So both samples, both locations, follow a significantly different distribution. That's basically what's said here. It cannot be assumed that both locations report the same structure with regards to rejection. Well, that's already everything there is to this session, to this exercise. So I hope you enjoyed it. If you want to see more of these types of exercises, feel free to visit the rest of the corresponding playlist. I say goodbye and see you next time.